Welcome to the final chapter of our course on quantum mechanics. So chapter 15 covers lasers and laser spectroscopy, and this is one of my favorite chapters to talk about because I love lasers. I think they're totally awesome, and I love the chance to get to talk about them. We're also going to include a little bit that's not in your textbook about a specific type of spectroscopy that is done using lasers, though it doesn't have to be done with lasers, it almost always is. Known as Raman Spectroscopy. So that's sort of a bonus that's going to be part of Chapter 15. It's a very useful technique and one that is widely used for many different reasons that we'll get to when we talk about Raman Spectroscopy. So why do I love lasers so much? What makes them so interesting? So lasers, well, first of all, laser is actually an acronym for light amplification by stimulated emission of radiation. And we'll go through what exactly this means as we talk through this chapter. But the basic idea here is that for a laser, we're using stimulated emission radiation, which we will discuss, to generate very bright sources of light. So lasers have turned out to be incredibly useful for all sorts of different applications, both for society and for chemistry specifically. So some of the societal impacts of lasers are the internet. So all the signals that get sent over fiber optic cables rely on lasers to send those signals. So that's, a pretty big deal. So all the signals that get sent over undersea cables, those are all fiber optic cables that are sending signals at the speed of light. So we literally use light to send our information. So as you're watching this video right now, there's probably a laser somewhere that's part of the transmission chain. Even something as simple as a supermarket scanner. So those rely on lasers to scan barcodes. Laser eye surgery. So lasers have turned out to be incredibly useful in medicine. Not laser eyes, laser eye surgery. And so those are just a few of the broad societal impacts. CDs, DVDs, Blu-rays, those all rely on lasers to be able to read the information off of the discs. And in terms of chemistry, and why I in particular think lasers are super useful and handy is they enable a lot of really interesting spectroscopic techniques. So I use lasers for my research, and there's certain things that we can only do with lasers that can't be done with more traditional light sources. Things like a UV vis spectrometer. Lasers give us access to very bright sources of light, and we're going to talk about only some. There's really more than we can talk about in this class. Some of the specific spectroscopic techniques that are available because of lasers. So these are some of the advantages here are you can get very sensitive measurements. So you can measure things with very low concentrations, fast. And here we're talking like femtoseconds, up to femtoseconds. We can measure things on very short time scales. So you can measure where energy goes in a molecule when it absorbs light, or things like that. So lasers are awesome. I guess is the short version. And in this chapter, we'll discuss how lasers work on a very fundamental level, and not go into a lot of the specific details of the engineering behind it, because there's also a lot there. And then talk about some of these applications in chemistry.